So this one is a structure pop quiz. In question one, list the oxides from A to H as shown: calcium oxide, aluminum oxide, silicon oxide, sulfur dioxide, carbon dioxide, iron 3 oxide, silver oxide, and carbon monoxide. Answer the following questions by using the oxides from A to H. Each letter may be used once, more than once, or not at all. So the first one is responsible for acid rain. So which oxide is responsible for acid rain? It should be an acidic oxide. So what are the acidic oxide? This is acidic. And carbon dioxide, the non-metal oxide are acidic, but mainly the sulfur dioxide, as it mix, it forms sulfurous acid, which will cause an acid rain. Has a giant covalent structure, which has a giant covalent structure when we check. So if you remember, we discussed the structure of silicon 4 oxide, that each silicon is bonded with 4 oxygen and the structure continue. So which is having a giant covalent structure. So silicon 4 oxide is having a giant covalent structure. That's why we will write C as a answer here. Is reducing agent in the blast furnace. In a blast furnace, what will happen? Yeah. In a blast furnace, what will happen? You can annotate on the screen and write the answer. That's good. I appreciate that. And I'll explain each part as well. So in a blast furnace, what will happen? So in a blast furnace, we have iron 3 oxide and we reacted with carbon monoxide. As a result, it will produce iron and carbon dioxide. So this is a reaction in a blast furnace. So what is happening here? That iron 3 oxide is being reduced and carbon monoxide is being oxidized. This change is oxidation because increase in oxygen number, and iron 3 oxide is this change is reduction because oxygen is removed. So for a substance which is oxidized, what it is acting? It is acting like a reducing agent. So in this case, the carbon monoxide is a reducing agent. So that is a question itself, that which of the oxide is acting as a reducing agent? Which of the oxide is acting as a reducing agent? That is carbon monoxide. Is the main constant of the bauxite? Is the main constant of the bauxite? So bauxite is ore of aluminium, and which mainly contain aluminium oxide and iron oxide as well, but mainly the main constituent of the bauxite is aluminium oxide. Structure pop quiz 13. 13. There's it's a main impurity of the ore of the iron. It's a main impurity of the ore of the iron. So what is the main impurity in the ore of the iron? Main impurity in the ore of the iron. So iron ore, which is hematite, what it contain? It contain an impurity silicon oxide. So how we remove, this is a main impurity in the ore of the iron. How we remove this silicon oxide? So we reacted with calcium oxide to form CaSiO3, which is a slag. So silicon oxide react with calcium oxide to form slag, but what is the main impurity in the ore of the iron? The main impurity is silicon 4 oxide. So C will be the right answer. Yeah. I have recorded the previous parts as well, so you can check the remaining. 13, the last week. Can be reduced by heating with copper. So can be reduced by heating with copper means this oxide, when we react with a copper, like this metal oxide, when we react with a copper, it can be reduced. So how we will know? It should be less reactive. The element, the oxide should be less reactive than copper. So if it was a silver 1 oxide, because if it's a silver oxide, because copper, when we check the reactivity series, copper is more reactive. So as a result, copper can remove this silver from its compound and it will form copper oxide plus silver metal. So what we want a less reactive metal oxide, a metal oxide which is less reactive than copper. Why? Because copper can reduce the metal from its oxide, so copper should be more reactive. So copper is more reactive than what? Copper is more reactive than silver. That's why the last one, silver, is a right answer. So the points which cause an acid rain, sulfur dioxide is causing an acid rain, which has a giant covalent structure. Silicon 4 oxide is having a giant covalent structure. Is what? I discussed that point again. So I'm recording the session. You can check that. Is a reducing agent in a blast furnace. So carbon monoxide is a reducing agent. Is a main constituent of the bauxite, aluminium oxide. Is a main impurity of the iron ore, silicon 4 oxide, and can be reduced by heating with copper. So it should be a less reactive metal oxide than copper. That's why it is silver. Question 2. Fluorine, chlorine, bromine are in a group 7 of the periodic table. State the name given to a group 7 element. What we call them? Good. So we call them as halogens. Or salt former we call. The term halogen refers to salt former. You can annotate on the screen to write. Explain why group 7 elements have a similar chemical property. Remember, chemical properties depends on the number of electron in the last shell. If they have the same number of electron in the last shell, means they will have the same chemical properties. Like if a same question they ask why group 1 is having a same chemical property, what you will write? Same number, same answer. Why group 2 is having a same chemical property? So you'll write the same answer. So this is a journal answer for all the groups. It's not for specifically group 7. You'll write the same. Complete the table 2.1 to show the color and the state at room temperature and pressure for a group 7 element. Fluorine appearance is given light yellow, pale yellow, and it is a gas at room temperature. It is yellowish green, and it is gas, or pale green you mentioned. And bromine is brown. Bromine itself is brown, but when bromine dissolve in water, it is orange. Aqueous bromine is orange. Brown, red brown. So we write red brown and it is liquid. Orange, I will see. Red brown is there. So it should be red brown. If it was aqueous bromine, so orange is not written there in the marking scheme, so you're not supposed to write orange. If they say aqueous bromine, bromine in water, then it should be orange. Question 3, chlorine displaces bromine from aqueous potassium bromide. Like we have a potassium bromide, KBr. When we reacted with chlorine, the chlorine displaces bromine. As a result, it will produce potassium chloride plus bromine. But does not displace fluorine from aqueous sodium fluoride. So if we have Cl2 plus K2 KBr, it should be balanced. Why it's of 2 marks? 1 mark is for writing a correct product, 1 mark is for balancing. So if we want to balance, we put 2 here and we put also 2 here.
Sir, I'm just asking in general, what would be the state of bromine after
This bromine is called aqueous bromine. It is dissolved in water. This is aqueous. This is aqueous and chlorine was bubbled, so it was a gas. Suggest why chlorine does not displace fluorine. So that's right, it is less reactive. That's why it cannot displace the fluorine from its compound. Always a more reactive displaces a less reactive. Less reactive cannot displace the more reactive. Aqueous silver nitrate is colorless, which contain a silver ion. Describe what is seen when a silver nitrate is added to sodium chloride. Whenever a salt contains a chloride ion and you add a silver nitrate, so what is the observation? The observation will be white precipitate. PPT in exam you can write. Instead of writing full precipitate, you can write PPT. If it was a bromine, like sodium bromide, then it will be cream color precipitate. No, cream, CREAM. And if it was iodide, then it will be yellow precipitate. Like these ions, you have to remember if a chloride ion is there, white. If a bromide ion is there, I'm not saying bromine, bromide ion, cream. And if it is iodide, it will be yellow. Write an ionic equation for a reaction between a silver nitrate and aqueous sodium. So we need an ionic equation. This is not right ionic equation for nitrate ion because it will form silver chloride. So we want to write a formation for a silver chloride. So silver chloride, how silver chloride is formed? So silver chloride, the solid silver chloride is formed by reaction of a silver ion and the chloride ion. So the silver ion reacted with the chloride ion to form silver chloride. When you are writing this equation, this is a full equation. They did not ask the full equation. They asked ionic equation. So in ionic equation, we are not supposed to write the whole formula of the compounds. What we have to write, we just have to write the ions which react to form the precipitate, the solid, liquid, or a gas. So here, if they ask write a full equation, then what will be the answer? That the silver nitrate, AgNO3, it reacted with sodium chloride to form silver chloride plus sodium nitrate. That will be the full equation. But because they are, and the state symbol, this will be aqueous, this will be aqueous, this will be solid, and this is aqueous. This is a full equation. But they ask for ionic equation. When we write an ionic equation, we write for solid, liquid, or a gas. We write for solid, liquid, or a gas. So what are the ions present here? It contains a silver ion and the chloride ion. And ions are aqueous and silver chloride is solid. This is the equation you are supposed to write. If you write this, you will lose the mark. You will not score the marks because this is a symbolic equation, not ionic equation, the full. So how you'll know what are the ions you have to include? You always include the solid, liquid, or a gas. So there are two products, silver chloride is there and sodium nitrate. But silver chloride is solid and sodium nitrate is aqueous. So when we write an ionic equation, we write for ion like for solid, liquid, or a gas. That's why we write an ionic equation for silver, not for sodium nitrate. It's a soluble or aqueous.